Hi and welcome to this new video. Have you ever wondered how speaker actually works? Like how they actually convert electric signal into sound waves? A very important topic to talk about, and I just want to analyze it and explain to you how a speaker actually works. How does it actually convert electric signals which you actually input to it into sound wave which you actually hear that is actually in our phones, and mobile phones, a Bluetooth device? A very important topic, and I want to really analyze it. And if you're kind of confused on how it actually works, you don't really know how it actually works, be sure to stay till the ending of this video to get great insight and full practical knowledge on how speaker actually works. I'm Success Very Money, and let's go into the video. Now, the first question comes like this: what is a speaker? How does speaker actually works? What is inside of the speaker, and what actually enables the speaker to convert electric signals into sound waves which you actually hear? Now, the two main parts which actually inside of the speaker, which is very important, which you really need to know as electronic enthusiasts, is actually the code. Yeah, the code is actually what is wrapped here, and the code is actually what enables the sound to actually come out. This is what actually vibrates the air and actually like create sound waves which you actually hear in our ears. Now, another layman language of actually explaining how speaker actually convert electric signals into sound waves is that it actually vibrates the air. It actually vibrates the air surrounding. You know that we actually breathing in air and we breathe out carbon dioxide. But yes, the speaker is actually what enables the air to vibrate. It actually vibrates the air, thereby it creates a sound wave which now goes to our ear, and we take it as a music or somebody says something or stuff like that. Now, to back what there's three main parts which are actually some of the speaker, just as I said, is actually the code. Now, inside of this code is actually a coil, just as I said in my other video, in my motor video. If you haven't watched my DC motor, yeah, I explain how DC motor actually works. Go check it right here. I explain about electromagnetism and stuff like that, and that is what we're also going to be explaining today. Not really a DC motor procedure, but kind of electromagnetic stuff. Anyways, there's actually a cone on this speaker that actually vibrates the air and create sound wave for us, and inside this code is actually connected to a coil. There's actually a coil which is actually wrapped on top of this cone, and it's the coil which actually enables the cone to move, thereby generating sound wave for us. Secondly, there's actually a permanent magnet inside of the speaker. You can see this bump right here. This bump right here is actually where the permanent magnet actually sits in. This permanent magnet is what actually helps speaker to function. Without the permanent magnet, it's not going to work. So the cone is very important, the permanent magnet is very important, and also you can see that there is a kind of a cover. Yeah, the cover is actually what keeps the speaker in place and keeps everything in place and like make the function to work properly. And you know, you cannot also keep everything outside. There's actually a cover and to cover everything in place and keep it protected so that it will function properly. Now, there's something I actually missed in my last clip. I actually said that a cone. A cone is one part. There's a coil. The coil is the second part, and there's also a permanent magnet. So just go from my last clip. The cone, the permanent magnet, and also the coil. Yeah, these are the three main parts that actually make the speaker to work. Without it, the speaker is not going to function. Now, how does the speaker actually work? How does it actually generate electricity? You're very curious about that, and that's why you click this video. Let's go into it. Now, firstly, these are two coils actually wrapped on top of the cone, as I said in my last clip, and the two coils actually connected out here, which you can see right here. Don't mind about the dial, I'm going to explain it later, but these are the two terminals of the coil, ending, the starting and the ending. So now these two terminals of the coil is which actually what you're going to put your electricity into it, which is actually going to generate sound wave for you. In that case, you're going to be putting AC, not DC. I'm going to be explaining that later on in this video. So now, when current flow into this coil, the coil actually turns to electromagnetic. That's actually explained in my DC motor. When you put flow electricity into a coil or a copper wire or a conductor, it's actually going to start producing electromagnetic field. Thereby, it now have north and south, as I explained in my DC motor. If you haven't checked that video right here, go check it right here. Anyways, that is what actually still happens here in the speaker. When current flows through this coil, the coil actually takes this current, actually turns to a magnetic field, electromagnetic, yeah, it actually turns from a normal wire to the electromagnetic, and that's now interface with the permanent magnet which is actually inside of this speaker, thereby generating sound wave. Actually, as I actually said in my earlier clip, I actually said that the coil is actually connected. The coil is actually rolled inside of this speaker, and that which the coil is built on is actually connected to the cone. So as the coil is moving, the cone is actually moving, that actually vibrates the air and generate the sound wave for us. So yes, when the current which you put into the speaker goes into the coil actually vibrates according to which the frequency which you actually put it in the speaker is, and actually vibrate because there is actually a permanent magnet inside, thereby generating the sound wave which you actually hear. Now, if you don't really understand the explanation on how I explain how the speaker actually works, don't worry, I'm going to be rephrasing that later in this video, but let's actually go to the second concept. I actually said in my last clip that the voltage you should actually need to put, the type of current you should actually feed into a speaker is actually AC. Now, is it actually AC or DC? It's not DC, it's actually AC, because AC is actually alternating. DC is just a straight line, while AC is actually alternating current. Just like I explain, if you don't actually understand AC current, I actually explain it right above here. So now, as I said, AC is actually alternating, which actually causes the vibration, but DC is not going to cause the vibration. DC is just going to push the cone straight ahead, but AC is actually alternating off and on, thereby causing a forward and backward movement, thereby causing a vibration and causing a sound wave. I don't know if you understand me. Earlier in this Philip actually said that there's a coil inside of this speaker, and the coil is actually wrapped on top of coil. Now, this coil is actually connected to this diaphragm, which is actually right here. This diaphragm is actually what enables the speaker to actually generate a sound wave. Without this diaphragm right here, it's not going to generate a sound wave. So as the coil is moving up and down, the diaphragm is also moving up and down, thereby vibrating the air and actually generating a sound wave. If you put a DC voltage in a speaker, it's just going to push up or it's going to push down one way, and because the DC is always straight, it's not going to shake the diaphragm, or it's not going to shake the cone, and it's not going to generate any sound wave. But AC is a backward and a forward movement, thereby generating a sound wave, thereby generating a vibration in the cone, thereby generating a sound. I don't know if you really get my point. Anyways, if you really want to get the main insight and kind of electronic full tutorials and educative knowledge like you do, to subscribe to my channel, which really mean a lot to me. And also, you can check my Patreon and join for free on your first month of subscription. You can get up to 90% off using the code I'll be pinning in this comment section, link in the description to join. Also, a very quick important case, the type of frequency which actually input in the speaker is actually what determines how the speaker is going to sound. Like this speaker is not actually a bass speaker. This speaker is actually a treble speaker, right? I guess it's actually a treble speaker type. And if you put high frequency, it's actually going to generate high pitch, thereby loud noise. But if you put low frequency, it's going to generate bass for you. But this speaker is not basically for bass, so it's not really going to work like that. Bass speakers are also almighty speakers, which you actually see right there. So this frequency which actually input into the speaker is actually what determines what type of sound is going to come out from the speaker. So that's just a quick idea I really need to share. Let's go to the next one. Now, as I actually said, I'm going to be explaining again how the speaker actually works if you don't really get what I actually said in the beginning. Now, first off, what you need to power to the speaker, as I said, I'm going to make it slow and steady, so pay attention. Now, first off, what you need to power to a speaker, the type of current which you need to input to a speaker is actually AC current, alternating current. I actually said go check the video if you don't know what AC current is. So when you put AC current into the speaker, there's actually a coil which is actually wrapped into the speaker. Now, this coil is actually what actually generates the sound wave. Now, I actually said there's a coil wrapped into the speaker. Now, the coil is actually wrapped on top of a cone, and this cone is actually connected to a diaphragm. This diaphragm is actually what generates the sound wave. So now, when this coil receives this electricity, it actually turns to an electromagnet, thereby interfacing with this permanent magnet which is actually inside of this speaker and making it to move back and forth. This back and forth movement is actually what vibrates this diaphragm right here, thereby generating the sound wave. So according to the frequency is high frequency or is low frequency, depends on how the diaphragm is going to shake, depends on how the coil is going to move up and down, and going to generate the sound wave and vibrate the diaphragm. This diaphragm is actually what is moved. The coil actually moves this diaphragm right here, and as the diaphragm is actually moving, it actually vibrates the air, and as it vibrates the air, is actually generating the sound wave which you actually hear in our ears. I hope you really understand it. I'm kind of really slow now, not my usual way, but if you want me to be, just let me know in the comment section and I will stick to it. Let's go to the next one. Now, I actually said I'm going to be explaining what this diode is actually doing right here. You can see this diode right here. Why is this diode right here? What is he actually doing? And why is there a diode in the speaker? It's really a great question, and I said I'm going to be answering that. Now, by the way, I got the speaker from a kit. It's actually come from a police siren kit. Yeah, the kit is actually a kit which is actually able to generate a siren, and this speaker is actually what connected to it. So this diode is actually what protects the speaker from spoiling the transistors and other delicate ICs which is actually inside of that kit. Now, you're going to be asking me what transistors and what ICs and what is actually going to spoil it. Now, when you actually put in power into this coil, when you actually put in power into the speaker actually turns to electromagnets. Now, I actually said that in my motor video that when you power a motor the motor actually spins and it's actually generated back EMF. Yeah, it's normal. The electromagnetic coil is actually inside there actually generate a back EMF, thereby making the motor to draw less power, as I explained in my motor video. If you haven't checked that yet, go check that. That will be the link in the description. So that is the same thing that happened right here. That's the same thing that also happened right here. There's also again a coil inside of the speaker. So when you put in voltage into this coil, the coil is actually what vibrates and vibrate the diaphragm to generate a sound wave, but it's actually generate a back EMF. Yeah, that back EMF is really dangerous and it can spoil electronic components or spoil transistors which the speaker is actually connected to. So this diode actually helps to shunt that high back EMF which is actually generated. It's actually going to shunt that electricity so that it will not serve as a dangerous act or serve as a dangerous scene to the transistors or the IC, or not to spoil them or stuff like that. So the diode is really important. But if you're not connected the speaker to any important electronic component, or you're not connected it to any important kit, you can just do away with the diode right here. It's really not important. But if you're connecting it to sensitive components, you really need to put the diode, and that's why the diode is right here. So now here is the speaker found. Where can we find speakers? Speakers are almost everywhere. Speakers are almost in all our electronic gadgets and phones and chargers, car, televisions, MP3, and a lot of stuff to generate sound wave for us. And I hope you really enjoyed this video. If this video was helpful, do to give me a subscribe and also like my videos. If you like what I do and want to support me in any way, that will be on the description. You can go and join my Patreon for free, or you can buy me a coffee. That will be a one-time payment. But if you want to support me monthly, you can go support me on my Patreon. 90% off on your first subscription. That will be in the link in the description. Thank you very much for watching. I'll see you guys in the next one.